We're going to look at slope and writing linear equations today, and the learning targets are that you can find slope, otherwise known as rate of change, and also that you can write the linear equation of a straight line. So this first problem, you can see this car driving up the incline. The grade of a road is a percent that measures the steepness of the road. It is found by dividing the amount the road rises, okay, this amount right here, divided by the corresponding horizontal distance, which is right here. Okay, that amount, that fraction or decimal, is also represented by slope. We say that slope is the rise over the run. Okay, run meaning your horizontal distance. So slope is a ratio of the change in your y, which we know y is up and down, to your x coordinates, which we know is horizontal. Same thing we just talked about. When a line rises, then it's going to have a positive vertical and horizontal distance. So your slope comes out to be positive when it rises to the right. If it decreases to the right, then you're going to get a negative slope. If it's a straight across horizontal line, your rise is 0 because you're not moving up or down. So you're going to get 0 over some other number. Okay, like maybe in this case, your horizontal run here is 4. 0 divided by 4 is 0. So the slope is 0. The one line that we can't do, or that doesn't have a slope, is a vertical line. Vertical line, we say, has an undefined slope, because if you were to find your rise over run here, the rise of this is 5. The horizontal run is 0 because you're not going left or right. Can you divide by 0? Nope. So that's where we say that this is undefined. Two other things you should know from geometry last year. Anytime your lines have the same slope, then that means that those lines are parallel to each other. So parallel lines have the same slope. Lines that are right angles to each other, like in this picture, those are called perpendicular lines. Perpendicular lines have slopes that are opposite reciprocals of each other. What that means is, say this line here has a slope of up 2 over 3. Then this line, we should know what the slope is, because opposite means it's going to have the opposite sign, so it's going to be negative instead of positive, like this line is because it's slanting up. The other thing we know about this line then is the slope is going to be the reciprocal. Reciprocal means flip the fraction, so the slope of this one would be -2 or -3 over 2. So it's always opposite reciprocals of each other. All right, so let's try one of these. Number 1 here, they want us to find the slope of the line passing through these points. Well, we can do this by finding rise over run. And another way of writing rise over run on these is to find the difference in your y's over the difference in your x's. So what we can do is subtract these, subtract the y's and subtract the x's. And it doesn't matter which order you want to do them as long as you do the same order each time. A lot of people, to start with, just like to kind of put x1, y1, x2, y2 to make sure they keep them straight. If that helps you do that. All right, so we're going to subtract our 2 y's here. We're going to subtract these. -2 minus 4. And then on bottom, we're going to subtract these two. 1 minus -1. So the slope then is the result we get. On top, we get -6. On bottom, remember, minus and negative is the same as plus. So we got -6 over 2, which means our slope here is going to be -3. Okay, slope of -3. On the next one, do the same thing to find slope. Subtract your y's. 2 minus 2. Subtract the x's. 3 minus -3. Well, here we get 0 on top. If we double slash or add, we're going to get 6 on the bottom. It's okay leaving the answer as 0 over 6, but even better, 0 divided by anything is 0. That one is going to have a slope of 0. It's a horizontal line. All right, number 2. We're going to do some graphing now. So now we want to combine what we know about points with what we know about slope and get a line. So they want us to graph a line that has a slope of 1/2 and that also passes through the point 2, -1. When you get these types of problems, you want to start with the point. Otherwise, you don't have a location to start with. So we want to first find where's the point 2, -1. Remember, x and y when you got a point. So now we want to go 2 to the right because it's positive and down 1, giving us this point. That's the point 2, -1. Now to get the rest of the line, we use the slope over here of 1/2. So now we're going up 1 because that's what the top is telling us. That's our vertical, and the bottom numbers are horizontal. That means it's positive. We want to go right 2, up 1, right 2, up 1, right 2, up 1, right 2. Or we could do the opposite, down 1, left 2, down 1, left 2. And if you connect those, you have your line. Why don't you pause the video and try the second one and see how you do on that? All right, let's see how you do. First, start with the point, -3, we want to move left. -4, we want to move down for our point. Again, remembering that that's x, that's y. The slope on this one was a little trickier. It was a whole number. Remember, with whole numbers, you can always put those over 1 to make them a fraction. So we want to start at this point, go down 3 and right 1. Down 3 points. Let's move this down a little bit here. Down 3, right 1. Or we could do the opposite. Up 3, left 1. Up 3, left 1. And connect them, and that's what the line should look like here. All right. Rate of change. Anytime you hear the word rate of change, immediately in your brain you should be thinking slope. Rate of change is just another way of saying slope. So it measures how much a quantity changes on average relative to another quantity, which is often going to be time. So any of these problems where they ask you to find rate of change or average rate of change, as you see here in this next problem, that's just saying slope. You're going to find it exactly like you would slope. So on number 3, Lynn is tracking the progress of her plant's growth since she bought it. The growth is modeled at the table shown. What is the average rate of change in the plant's growth per day? Okay, so on a problem like this, you want to figure out here what's your x and what's your y. X, y, okay, and then find the slope. So our average rate of change is going to be how much it changed per day. And you can get that by picking 2 points here. Let's pick the first 2 and find that out. So we want to subtract our y's on top, 7.5 minus 6, over our x's, which is the time here on bottom, 3 minus 2, and the result should tell us how fast this is growing on average. On top we get 1.5, on bottom we get 1. 1.5 divided by 1 is 1.5, and then the units would be centimeters per day. So on average it's growing 1.5 centimeters each day. What is the starting height for the plant? Well, they don't give us that in the problem, but we could figure it out by kind of going backwards here. Okay, so we got on our table, okay, this is after 2 days, 3 days, and 4 days. What would this look like if we went backwards and had 1 day and 0 days? Because 0 is where we want to find, that's our starting height. Well, we know we found this slope of 1.5 every time. It's adding 1.5 here to the previous one. Whoop. It's adding 1.5, so we just want to do the opposite then and minus 1.5 from each. So if we take 6 and minus 1.5, we would get to 5.5. If we minus 1.5 again, it looks like at the start it had a height of 4 centimeters. Another way you could do that would be to take the first one you know here, 6, okay? We know the slope is 1.5 each day. We got to go backwards 1, 2 days. So take that and times by 2, and you'd get the same thing. 6, or 1.5 times 2 is going to be 3. And then 6 minus, oh, sorry. I did some bad math here. This, going back here, 6 minus 5.5 is 4.5, and that would be 3. And so 1.5 times 2 is 3. You subtract it. Looks like 3 centimeters was the starting amount. Okay, so that would be another way you could go about that problem. Last one, or sorry, new problem. Oh, never mind. Part C. Write a linear model that represents the height. Okay, linear model means write an equation in slope-intercept form. We talked about that looks like this. So your slope, we know, is 1.5. That goes in for M. Our B is the starting amount. That's what it was at day 0. That would be 3. That equation then could be used to find the plant after any days. And I suppose it says D days here, so if we want to use D instead of X, we could do that. So now if you put any amount of days in for D, you could figure out how big this plant's going to be. Okay, next one. Kevin's savings account balance has changed from $1,140 in January to $1,450 in April. Find the average rate of change per month. Okay, average rate of change, Y's and X's again. Now here you only see that you got these two numbers. Okay, what's our other change from? Well, they kind of give you a clue here at the end per month. That means on bottom we want our months. And on top, then we're going to have our money up here. So we got to find what's the change in money over the change in months. The change in money would be subtracting these. Okay, the change in months, you're going to have to figure out, well, how many months is it between January and February? Well, you got January, February, March, April. Looks like it's 4 months. So now if you subtract these and divide, you're going to get $77.50 per month. Would be the answer. So average rate of change, you got to make sure you're finding the change on both top and bottom. Okay, another thing that you should be able to do is write the equation when you're given the slope and any other points. Even if it's not the y-intercept, this point, we should still be able to come up with a y equals mx plus b equation. So to do that, if you're given a slope and a point, we're going to use this equation to help us, called the Pointslope form of an equation. And how you can use that is to use the point and put that in for x1 and y1, and put the slope in for m, just like we did before. So on number 5, they give us a slope here. Our slope is going to be -3/2, and we're given a point right here. So that means -4 is going to be our x1, 1 is going to be our y1. So if we put all that information into this equation, you can find the slope of the line. So now plug it in. We got -3/2 here. X and y are just part of the equation. Plug in the point we have, -4 and 1. If we simplify that now, that should simplify into slope-intercept form. Start out by distributing. Multiply to both here. Now, even before we do that, it probably would be good if we change this to a plus, because we're minus the negative. So -3/2 times x, -3/2 x, -3/2 times 4. That one a little bit tougher. If you need to use a calculator, do it. If we do -3/2 times 4, 4 is a whole number. If we wanted to make it into a fraction like our other number, we can put it over 1. And then when you multiply fractions, you just multiply across the numerator and across the denominator. So we would get negative, because the first one's negative, the second one's positive. 3 times 4 is 12. 2 times 1 is 2. -12 divided by 2 is going to be -6. Okay, now on the other side, we still got that y minus 1. We're almost the slope-intercept form. If we just add 1 to both sides, we have our answer. We get that y equals negative 3 halves x. Be careful on this one. It's not 7 because we got a negative here. It's negative 6 plus 1. That would be negative 5. Now we got an answer in slope-intercept form. All right, let's check out another problem here. Okay, so the next one, number 6, they want us to write the equation of in slope-intercept form for the line that passes through these 2 points. All right, now we got 2 points, right? We want to still be able to write the equation. If you're given 2 points, we want to find the slope and plug the slope in one of those 2 points and still use that point slope form. So just like we did very beginning of the notes, find the slope. We got 2 points, we can always find slope. So do your y1 minus, or y2 minus y1 over x2 minus x1, just like we did at the beginning, and we can get that. So we got 5 minus 4 over negative 4 minus negative 1. Looks like our slope here is going to be 1 over, probably want to add this here, negative 4 plus 1 is going to be negative 3. Okay, so that's our slope. That's our m. Now we want to use that with one of these 2 points to get the equation. And it doesn't matter which one you use, you're going to get the same answer no matter what. I'm just going to pick the first one here. It doesn't really matter. So now put it into this point slope form like we did before to get our solution. So doing that, we got y minus, we're using this point, so this is going to be 4 equals, our slope is negative 1/3, x minus, and our x was negative 1. All right, again, let's make this into a plus. Distribute. So you got negative 1/3 x. Negative 1/3 times 1 is going to be negative 1/3. Last step, we want to add 4 to both sides. And we're going to get y equals negative 1/3 x. 4 plus a negative 1/3 would be 3 2/3. Or another way of writing that would be to multiply the 2 3's, which is 9, and add the 2. So we could also write that as negative 1/3 x plus 9 plus 2 is 11 thirds. So that would be the answer for that one. All right, one more here, number 7. And this one says write the equation in slope-intercept form for a line parallel to the line given and that passes through the point 2, 3. All right, well, we know that when lines are parallel, they should have the same slope. Okay, so we want to know in this line, what is that slope? The slope here is 3. That means the slope of this line is 3. The slope of this line should also be 3. What you got to realize in this problem is this plus 1 means nothing to the problem. Okay, it's just some other line. We don't really care what that 1 is talking about. Don't feel that you need to use everything that you're given. We want a line now that has a slope of 3 and goes through this point. So now use that point slope form again and you can get the equation of this line. It would be y minus, our y1 is 3, our slope is also 3, and our x1 is 2. If we simplify this, this should get us the slope-intercept form. Distribute, add 3 to both sides, and this would be the equation of the line. Last one. As a salesperson, Eric is paid a daily salary plus commission. Okay, commission, that's where you get like a percentage of whatever you sell. A lot of people are paid that way when they're in sales. So it says when his sales are $1,000, he makes 100. When his sales are 1,400, he makes $120. Write a linear equation to model this situation. So what we want to do is come up with some ordered pairs that we could use then to find out how much he makes. So our ordered pairs here are when he sells 1,000, okay? When he sells 1,000, he makes $100. Okay. It also tells us when his sales are 14, he makes 120. We want to now use these to make an equation. Well, whenever you got 2 points, you can find slope. So the first thing, find the slope on this one. So if we put in our y2 and y1, we got 120 minus 100 over 1,400 minus 1,000. Looks like we get 20 on top, 400 on bottom. If we divide that, we're not going to get a whole number, but what we could do is simplify it a little bit here. We could divide both of these by 10, and now we got 2 over 40. And we could simplify that. 2 goes into both of those, so it's simplified to 1 over 20. Looks like our slope is 1 over 20. Okay, now pick one of the 2 points, this one or this one, and put it in a point slope form. So we got y minus, let's just use this first one here, 100 equals our slope, x minus 1,000. Distribute, so you got 1 over 20x, 1 over 20 times 1,000. You could do that, that'd probably be a good one for the calculator here, or you should be able to do it without it. 1 over 20 times 1,000 should give us, I think, 50. Yep, 50. And be minus 50 because it's minus it. Now add 100 to both sides. And we should get the answer here. Looks like 1 over 20x plus negative 50 plus 100 is 50. So now whatever his sales are, you could put it in for x and times it by 1 over 20, add 50, and that's going to be his commission for that amount. All right, you try some of them now on the practice sheet.